Hello dear students, this is Dr. Vijaya Babu. So in continuation with the previous lecture of mesh analysis, I have made you understand the procedure what to be followed in the mesh analysis. Now today we'll try to go ahead with the problems. So here, so in this lecture, so we'll try to go ahead with the problems of case 1. So that is case 1. Usually I am treating this as the problems with only dependent sources. So there are no independent sources in the circuit. Now, so if you try to understand this problem is given with 15 volts battery, 10 volts battery. So two batteries are given, both are independent sources, and the question he is asking what? Vx equal to how much and Ix equal to how much? Okay, using mesh analysis you have to solve this. You can apply any approach. Actually you have a lot of methods in network analysis. So also you can apply nodal analysis approach also for this problem, but strictly he is saying to apply the mesh analysis. So we'll try to go ahead in applying the mesh analysis for this problem. So many of the students, what the mistake you do here in this is directly now you indicate the mesh currents. So but what I'm saying is my sincere advice, guys. So to avoid the mistakes, so whatever the unknowns being asked in the question, so that you try to remove them. So that means you try to removing them and try to redraw the circuit. So I think this logic already I have explained you in the previous lectures. Redraw the circuit as follows. So how I am redrawing the circuit, just carefully observe. So this is plus minus 15 volts, 5 ohms, 10 ohms, eliminate Ix, 10 volts, 6 ohms, 4 ohms, so I have removed Vx and I have removed Ix. Why I have done this? Because now circuit is in my control. So to get the circuit in my control, so why to worry with that Vx and Ix now? It is not required. So once you apply the mesh analysis procedure and once we getting the mesh currents, then lastly once again you come back, then you will observe what is Ix and what is Vx, where are they located, then we will be calculating them at last. So now try to avoid them or remove them, that is Vx and Ix. So I have removed in the circuit and the circuit now is in my control. Now I will try to go with the standard procedure. So the standard procedure, what I said is, first of all identify the number of loops. There are 2 loops are there. So indicate the mesh currents clockwise direction. This current as I1 and this current as I2. So 2 currents I have taken, both are clockwise, or else you can take I1 clockwise, I2 anti-clockwise, I said. So now applying the KVL in this loop. So I'll try to take the red color and I'll try to walk along the loop. So I walk in this direction. Immediately you might be having a doubt that is it required to walk in this direction, why can't opposite? That means anti-clockwise can't I walk? Yes, you can walk. So you can walk anyway as you want on the loop. But whenever you are walking, as I said earlier, the current coming with you is always your friend, take it as positive. Current coming opposite to you is always your enemy, take it as negative. So that is most important simple logic that you need to observe while writing the KVL in the first loop and the KVL in the second loop. So I am walking like this. First of all, I am touching the negative battery, that is minus 15. I am touching. Then I am here. Then I am here. Now there is a voltage drop across the 5 ohm resistor. Yes or no? So voltage drop across the 5 ohm resistor. Observe the loop current I1. I1 is coming with you, so it is your friend. So that is why plus 5 into plus I1. I1 nowhere connected to 5 ohm resistor, right? Now going ahead. So I am here now. I have crossed this. That means I added the drop. Then I am here. Then I am here. Now I am at 10 ohms resistor. In the 10 ohm resistor, so if you clearly observe, current I1 is coming with you, so then compulsory I1 is your friend, but come the I2 mesh current, it is coming opposite to you, so that means it is always how much? Minus I2, because it is your enemy now. Okay, so now I'll try to show you with the red color where you are. So you are ahead of the battery of 10 volts. Okay, now you are ahead of the battery of the 10 volts. So then in this case, you are touching the positive terminal first, right? So then immediately you need to take plus 10 volts. Very important. Then you are crossed the battery, you are here, you are here. There is no drop across the conductor because it is an equipotential body. Okay, so you come back to the original position. That means this is exactly equal to 0. Okay, so rearranging the terms, so this is 10I1 plus 5I1, so 15I1 minus 10I2, okay, is equal to 5. Take it as equation 1. Okay, now, so I will try to show you with the black color now. So I'll try to walk in the second loop to apply KVL. Okay, so this is KVL in first loop, this is KVL in second loop. I'm going ahead. So applying KVL in the second loop, I can walk any direction. I can walk clockwise in the entire loop, or else I can walk in the anti-clockwise. Okay, so no issues. I start here. I walk in this direction. Okay, I am touching 4 ohms now. But coming to the current through the 4 ohms, it is I2, but it is coming opposite to you, right? So it is your enemy now. Take it as minus I2. Then you are here. Then you are here. Okay, plus 6. Once again, 6 ohms resistor is in connection with current I2 only. I2 is flowing through 6 ohm, but it is opposite to you. That is why here also current is your enemy. So that is why it is minus I2. Then you are here. You are in front of the 10 ohm resistor now. Okay, so you are in front of the 10 ohm resistor. Then plus 10 into. Now understand, I2 is coming opposite to you. So it is your enemy. Compulsory. But I1 is your friend because it is coming with you in your direction. So that means this is plus I1. Then you have crossed the 10 ohms. You are ahead of the 10 volts battery. You are touching the positive terminal of the battery. So this is plus 10. Then you have crossed the battery. You have crossed the, you are crossing this conductor. Conductor is equipotential body. There is no drop. So that is why nothing to add here. And finally, you come back to the original position. So that is exactly equal to 0. This is equation 2. Okay, or else rearranging the terms. So it is simply 10I1. Okay, so minus 6I2 minus 4I2 minus 10I2 minus 10I2. Total minus 20I2 is equal to 0. So sorry, is equal to minus 10. This is equation 2. Upon solving the equations 1 and 2, you will be getting I1 as 1 ampere and I2 is also 1 ampere. So this is how you can calculate the mesh currents. But this is not our target na. So we need to compulsory calculate the value of Vx and Ix. So we'll go back to the problem once again. So we'll try to calculate Vx and Ix. So this is I1 is 1 ampere, I2 is 1 ampere. So if you clearly observe here, so I'll try to show with the green color. So that means a loop current 1 ampere this way and a loop current 1 ampere this way. Okay, so now that means this is 1 ampere, 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 this is 1 ampere. This is regarding I1. Coming to I2. Okay, so this is 1 ampere, this is 1 ampere, so this is 1 ampere, this is 1 ampere, and 1 ampere coming opposite, right? So that means the net current becomes 0 ampere. The net current becomes 0 ampere because I1 is coming clockwise. Okay, I2 is coming also clockwise, but in the branch of 10 ohms, okay, I1 is coming down. That means 1 ampere is coming down and 1 ampere is going up. Both will cancel with each other. So the net current in this 10 ohms branch is 0 amperes. Okay. Now coming to the value of Vx. Vx, I try to draw this separately. So this is plus minus Vx. So resistor is 4 ohms and the current coming here is 1 ampere. Okay. So the value of Vx is directly current entering the positive terminal of Vx. Na? So the answer is simply 4 into 1. So which is equal to 4 volts. Then coming to the Ix, however, the current in that branch of 10 ohms branch should have 0. Na? So this is 0. So Vx equal to 4 volts and Ix value is equal to 0 amperes. So this is how you need to calculate the respective unknowns once you got the mesh analysis solutions, that is mesh currents. Okay. So this procedure can be applied for any type of circuit which is having the only dependent sources. I'm calling it as a case 1 problem because there are two equations, equation 1 and equation 2, and there are only two unknowns. Whenever the number of equations, okay, mesh equations or loop equations or KVLs is exactly equal to number of unknowns, so this automatically comes under case 1 problem. So that is the problem with only dependent sources. So whenever we will go for the case 2 problem, that is the independent sources, okay, the number of loop equations or KVL equations or the number of mesh equations are not sufficient to solve the problem. So then we will try to understand in the next video lectures, so how can we solve that type of problems under case 2. Okay, so thank you for giving this opportunity. If you really enjoy this video, just like and subscribe for the channel. So also you can comment it so that it will encourage for us to do lot more videos. So thank you so much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.